All right, so today we're going to look at writing all the conditional statements and tell them whether they're true or false. If they are false, we're going to provide a counterexample for each of them. All right, so let's look at this statement. It says, if an angle is obtuse, then it has a measure of 100 degrees. Okay, so let's talk about what that means first. So obtuse means an angle that's bigger than 90 degrees, right? All right, so it's a measure of 100 degrees. All right, so we broke that down. Now, what's the hypothesis here? Well, the hypothesis, or P, is going to be an angle is obtuse. That's P. Q is going to be it has a measure of 100 degrees. Okay? All right, so let's take a look at this original statement here. If an angle is obtuse, then it has a measure of 100 degrees. All right, so can I have an obtuse angle? That's what you have to ask yourself. Can P happen? Yes, it can. We can have an obtuse angle. Now, the question is, does that obtuse angle always have to be 100 degrees? And when I ask that, you should think about that and say, no, there's tons of angles that are not 100 degrees but are obtuse. So this is really false, isn't it? And the reason why it's false is because I can be able to provide a counterexample. Anything that is obtuse that's not 100 degrees. So you can just give me a measurement. You could say 150 degrees. That's obtuse, right? It's not 100 degrees. So that's false. All right, so let's look at the converse of this. If you remember, the converse is Q implies P. So that would be if, we don't want to say if it, we want to say what is it is an angle. So we want to say if an angle, because we're moving that, remember? We're taking this conclusion and moving it where the hypothesis is. So if an angle has a measure of 100 degrees, then it is obtuse. So what I did was I took the conclusion and I moved it to where it's going to now be the hypothesis, right? And I switched them. So I switched P and Q. All right, so let's read it now. If an angle has a measure of 100 degrees, remember I changed that instead of saying it has a measure because it just doesn't make sense. You can't just describe me it before I know what it is. And it's an angle, right? So if an angle has a measure of 100 degrees, then it is obtuse. All right, so can I have an angle that's 100 degrees? Yes, I can have an angle that's 100 degrees. Is it obtuse? Yes, if it's 100 degrees, it's obtuse. So this statement's actually true. So see how the first statement was false, but then when I switched it, the converse is true. So I don't have to provide a counterexample. All right, so the inverse is not P implies not Q, or the negation of that, right? So that's going to be if an angle is not obtuse. I wouldn't go ahead and change it to like right or acute because that's taking it too far. We're just saying it's not obtuse. So if an angle is not obtuse, then it does not have a measure, right? Excuse my handwriting, it's garbage, I know. So if an angle is not obtuse, then it doesn't have a measure of 100 degrees. Okay, so can I have an angle that's not obtuse? Yeah, I can have an angle that's right. I can have a straight angle. I can have an acute angle. Now, if it's not obtuse, then that means it doesn't have a measure of 100 degrees then, right? So think about this. I have an angle measurement. It's not obtuse. So that means it can't be 100 degrees, which is what this is actually saying, that it's not going to be 100 degrees. So this is true. Okay, that's a true statement. So I have an angle that's not obtuse, therefore it's not 100. Can't be 100 because that's obtuse, right? All right, so let's look at the contrapositive, which is not Q implies not P. So that would be the inverse, right, of the converse up here. So if an angle does not or doesn't have a measure of 100 degrees, then it is not obtuse. So if an angle doesn't have a measure of 100 degrees, then it is not obtuse. All right, so I don't have a measure of 100 degrees. Does that mean that my angle is not obtuse? Is there a time when it could be obtuse? Sure. This is false because my angle could be any measure that's not 100 degrees but is still obtuse. So I could say 150 again if I want to for my counterexample. Because 150 degrees, it's not a measure of 100, but it is obtuse, so that proves this part wrong, right? So every time we're trying to prove these things wrong or true, we're looking at the conclusion and we're saying, okay, does this happen all the time? Because if it doesn't happen all the time, then it can't be true, right? There's a time when it doesn't occur, so that means it makes it false. So you have to think about that. Now, one thing that will help you, because sometimes it can be confusing, this one probably was pretty easy to understand. Even this one here was probably pretty easy to understand. And then when you start to get to here, it you kind of get lost a little bit in terms of the truth values. Well, here's an easy way to remember it. If you look at the original conditional statement and you look at the contrapositive, they have the same truth value. Both of those are false. And if you look at the converse and you look at the inverse, they have the same truth value. Both of those are true. Now, that's not how it is all the time. They're not always going to both be true or false, right? They could all be true and they could all be false. But I will tell you this, that this statement here, this P implies Q, is always going to have the same truth value as the contrapositive. And the converse is always going to have the same truth value as the inverse. So if you get confused and you're like, well, I think that should be false, check your converse. If your converse is true, then your inverse is true. If your converse is false, then your inverse is false. And 9 chances out of 10, you can use the same counterexample to disprove it. Same thing with your conditional statement and contrapositive. The conditional statement is always going to have the same truth value as the contrapositive. So if it's false, that has to be false. What that means is, there's a term for that, and it's called logically equivalent. And what that means is basically, if I know what P implies Q is, then I know what not Q implies not P is, which is the conditional and the contrapositive. You will know their truth values. As long as you know one of them, you know them all. Okay? So as long as you know this one, then you know this one down here. If you know this one, then you know this one here. So what happens if the conditional statement and the converse are both true? Then I automatically know the rest of them are true, right? What happens if they're both false? Well, then I know the rest of them are false. So that helps you kind of whenever you're thinking about it, because I can understand it gets a little confusing at times. All right, peace out.